Okay, so let's make sure we have the simplification procedure down. And the way we do that is to just work example after example after example. All right, so example 1, completely simplify each radical. Notice all the radicals in this example are square roots. Okay, so we're going to start with square roots and then we'll try cube roots and fourth roots and see how we do. Part A tells me to simplify the square root of 72. So my first step when I'm simplifying a square root or any root is to go ahead and build my factor tree for 72. So let me do that. Now when you build your factor tree, make sure that you keep factoring until you cannot go any further. So for example, when I break 72 down into 9 times 8, I then broke 9 down again into 3 times 3. And I broke 8 down again into 4 times 2. But then 4 keeps going into 2 times 2. Then what you do is you focus on the bottommost numbers, the leaves of the tree. And those bottom numbers tell you that root 72 is equal to square root of 3 times 3 times 2 times 2 times 2. And that means we can proceed to our second step and circle groups of n factors. Now, n in this case is 2 because we're dealing with a square root. So I'm going to look here at my group of 2 identical factors and then here at another group of 2 identical factors. These are going to come out of the square root because the square root takes 2 identical factors and gives you a single back. So root 72 is going to equal 3 on the outside of the root times 2 on the outside of the root, and then you still have this 2 left underneath, so root 2. Everything's connected by multiplication because everything was connected by multiplication here. Therefore, altogether we have 6 root 2. So square root of 72 is equal to 6 root 2. Alright, so next we have the square root of 432 to deal with. Now, 432 seems like a big number, okay, but it's not too bad because you can build the factor tree by simply using the fact that it's even, right? So let's factor down 432. You know that 2 goes into it 216 times. Because 2 times 216 will give you 432. And then 216 you can break down with a 2 again. And that'll be 108. And then this guy you can break down with a 2 again. And then 54 breaks down. And you have a 3 and a 3. And a 3 and a 2. So there's my factor tree for 432. Now, let me go ahead and save a little bit of time by looking for my identical factors right here in the factor tree. Okay, 432 has a pair of identical 2's right here. It has another pair of identical 2's right here. And then it has a pair of identical 3's. Which means on the outside I'm going to have a 2, a 2, and a 3, because that's what my square root does. It takes identical factors and gives you a single representative back. And then on the inside I'm going to have this lonely 3 left over. So using these groupings, I can jump straight from the factor tree to the simplified form. Root 432 is going to be equal to, let's see, on the outside I have a 2, and a 3 being multiplied. And on the inside of the square root I still have a 3 left. So altogether 2 times 2 is 4, times 3 is 12. Root 432 is equal to 12 root 3. On to part C, where we have another square root to simplify, the square root of 625. Even though 625 is sort of a big number, it's actually easy to factor. Okay, so when we try to simplify this square root, we are going to start just like usual by building our factor tree. And the first thing you should notice is that this number ends in a 5. When a number ends in a 5, that means that 5 goes into it. And so if you divide it out, you see that 5 goes into 625 125 times. So then this number can be broken down again, and it ends in a 5. So 5 goes into that 25 times. And then this can be broken down again, 5 times 5. So in order to simplify the square root of 625, we factor it down. If you look at the last numbers, the leaves, those are your prime factors. So we're going to circle pairs of prime factors. Right? This pair of 5s is going to come out of the square root as a single 5, and this pair of 5s is going to come out of the square root as a single 5. So what happens is the square root of 625 is equal to a 5 on the outside times another 5 on the outside times the square root of, well, since there was no prime factors left on the inside, you can actually write a 1. Right? Since this is 625 times 1 to begin with. But it's really silly to write square root of 1, which means we're just going to evaluate that. Square root of 1 is 1. So altogether, the square root of 625 is just 5 times 5, which is 25. Okay, so if all your prime factors come out of the square root, or come out of whatever radical you're working with, then all you have left inside the square root is a 1, but the square root of 1 is just 1, which means you don't even need to write it, and you can just write the product of the numbers that came out. For part D, we have to simplify the square root of 30. Okay, so we proceed just like usual. We're going to try to factor down 30. 30 is 6 times 5, and 6 can go further into 3 times 2. But if you look now at your leaves at the end of your factor tree, you see that there are no groups of 2 identical factors. All you have are 3 different factors, 5, 2, and 3. What that means is that the square root of 30 does not simplify, okay, because there's no pairs of factors that we can pull out. So if you ever run into the situation where you can't factor anything out of the square root, if you don't have any pairs or any groups of n identical factors, then your radical does not simplify. All right, on to example 2. The instructions here say completely simplify each radical. So we're doing the same thing, but now we have different types of radicals to deal with. We have a cube root, a fourth root, and a fifth root. So let's just start with part A and follow our steps. Now, the first step when you're simplifying any type of radical is to factor the number inside the radical. So there's our factor tree for 54. Breaks down to 9 times 6, and then the 9 and 6 break down. Right. At this point, you have to pay special attention to the type of root you have. Right. This is a cube root. That means we want to look for groups of 3 identical factors. Okay. So I'm not just going to circle 2 of these factors. I'm going to circle all 3 because I'm dealing with a cube root. The cube root is going to take these 3 identical factors and pull a single one of them outside. And then inside, we still have the 2 left. So the cube root of 54 altogether is going to be equal to a 3 on the outside and then a 2 on the inside. Now, be careful when you're writing this. Make sure that you include the cube root in your answer. Okay? Because we started with a cube root, we are definitely going to finish with a cube root. Okay, the next radical we have to simplify is the fourth root of 48. So we start just like before. We factor down the 48. So there's our factor tree for 48. Breaks down to 8 and 6. Then the 8 breaks down and the 6 breaks down. Because we have a fourth root, at this point we're going to be looking for a group of 4 identical factors. So if you look only at the prime factors, only at the bottommost numbers, then you see that there's 4 2's right here. All 4 of those 2's are going to come out of the fourth root as a single 2, because that's what the fourth root does. It turns groups of 4 identical factors into a single. And then we'll still have a 3 left on the inside because he's got no buddies. Right, that means the fourth root of 48 is equal to a single 2 on the outside times the fourth root of 3. So this 3 stays on the inside of a fourth root. Again, because we started with a fourth root, we're going to end with a fourth root. So there's our simplified form. All right, for part C, we have to simplify the fifth root of negative 160. So let's deal with this negative first. Okay, the fifth root of negative 160 is going to be the fifth root, all right, of negative 1 times 160. Okay, so you want to think of that negative as a negative 1. And then our product rule says we can split that apart into the fifth root of negative 1 times the fifth root of 160. The fifth root of negative 1, I know, hopefully. Okay, what number can I multiply by itself 5 times to get negative 1? Well, negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Right, so the fifth root of negative 1 is just, again, negative 1. Okay, so in general, when you have an odd root with a negative inside, you can pull the negative outside. Now you got to be careful though, because if you have an even root, if this were a 4, like the fourth root of negative 160, then the radical would not be a real number. Right? Negatives underneath even roots turn into not real numbers. But in this case we had an odd root, so the negative comes out. The next thing we have to do is factor down 160. So there's our factor tree for 160. Broke it down into 16 and 10, and then each of those broke down further. Right. Next, because we're dealing with a fifth root, we need to look for a group of 5 identical factors. It just so happens that there's 5 2's. There's 5 prime factors of 2 in 160. So those 5 2's will come out of the fifth root as a single 2, and then this 5 will stay inside. So at the end of the day, the fifth root of negative 160 was equal to the negative fifth root of positive 160. That's what we did first. And that's equal to 2 times the fifth root of 5. So this negative comes from here. Then I have a 2 on the outside. Then I have a fifth root, because we were dealing with a fifth root the whole time. And then there's still a 5 left on the inside. So all in all, the fifth root of negative 160 is negative 2 fifth roots of 5. Ooh, that was a good workout.